So now we're going to be talking about the 2022 AMC 10A problem 22. Suppose that 13 cards numbered 1, 2, 3, all the way to 13 are arranged in a row. The task is to pick them up numerically in numerically increasing order, working repeatedly from left to right. In the example below, cards 1, 2, 3 are picked up on the first pass, 4, 5 on the second pass, 6 on the third pass, 7, 8, 9, 10 on the fourth pass, and 11, 12, 13 on the fifth pass. For how many of the 13 factorial possible orderings of the cards will the 13 cards be picked up in exactly 2 passes? So let's just solve this problem now. So this problem is really simple if you think about it in the correct logic. So let's first start with analyzing what this problem actually means by a pass. So for a pass, you have to start with like the next number in the sequence. For example, 1 is the first number, right? So you can start with 1, and then you can start with 1, and then you go, you move from left to right, so you go right, and you see if any number is 1 larger than 1. Like you want to find 2 in the right side, and you find 2 here, and then you want to find 3, which is also here. After 3, you want to find 4, but there's no 4 to the right side of 3, so this is 1 pass, and then you start again. This time you start with finding 4, and you want to find 5 at the right of 4, so 5 is right here, and you can't find 6. 6 is not to the right of 5, so you start again. And this time 6 is here, and you want to find 7, but 7 is not to the right of 6, so you start again. So you have 7, and you want to find 8, you want to find 9, you want to find 10. 11 is not to the right of 10, so you start again. You start with 11, and you have 12, and then 13, and 13 is the last number, so this thing ends. So this is how the passes work. So based on this, we know that we want the 13 cards to be picked up in exactly 2 passes, meaning that these cards can't be exactly in order, but they can't be too messy either. They have to be picked up in 2 passes. So what this means, and we know that for one card, so for this random card with number A on it, it either is in the first pass or it's in the second pass. So there's 2 cases for each card, and there's 13 cards, so there's 2 to the power of 13 cases, and that's the number of cases for the 13 cards to get into 2 passes. But the problem is there's some special cases we need to exclude before choosing our answer choice. So what are the special cases? The first case is when every single card is in order, it's from 1, 2, 3 all the way to 13. So you can allocate them to first and second passes, but they might still be all in order in the arrangement. So you have to -1. And the second case would be when the first case would be when all the cards are in order, and the second case, when all the cards are chosen to be in the first pass. The second case would be when all the cards are chosen to be in the second pass. So these 2 cases both don't work because we need at least 1 card in both of the 2 passes. And another case, and other cases considered to exclude are, the 12 cases where the cards from the first pass are all in front of the cards from the second pass. For example, if I chose 1, 2, 3, 4 for the first pass, and I chose 5, 6, 7, 8, 9, 10, 11, 12, 13 for my second pass, if I order the cards in this order, this won't work out well, because now basically I don't need the first pass and second pass. I can just pick up all these 13 cards in 1 pass, so that won't work well. And how much ways are there to choose the first pass such that the cards in the first pass are numerically increasing strictly by 1? Well, there's 12 ways to do so, because you can start from 1, 1, 2, 1, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, etc., all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you can leave the 13 cards for the second pass. So there's 12 ways to do so. So there's 12 ways where the first cards in the first pass are all in front of the cards in the second pass, so that we have to exclude those 12 cases. And I don't think there's any more cases, so we can calculate this. We know that 2 to the power of 10 is 1024. So this thing is just 1024 times 8. 1024 times 8 is going to be 8192. Now minus 14. Now 8192 minus 14 is just 8178, which is our answer.